Okay, so the last thing I want to do in this section is give you a couple examples, a couple things to look for, and some pointers in doing the homework. There's a couple situations where we're going to deal with similar triangles that are kind of important for you guys to know because they show up a few times. The first one is where you have a triangle inside of another triangle, okay? So let's take a look at an example here. Say I draw this triangle, and inside this triangle I put another triangle with a line that's parallel to one of the other sides. Okay, so for instance, you might have one, I'll put it over here. So there's a second triangle inside the bigger one, right? A smaller one inside the bigger one. In fact, maybe I'll draw that in another color so that it stands out a little bit more. That might be a little bit better, okay? Okay, so now, as long as the two sides here are parallel, we have similar triangles. I'll kind of explain that for a moment. So this line and this line need to be parallel for this to work. First of all, you can see that they have the same angle down here on the left. Okay, if they have the same angle, it's going to be congruent to itself, right? So I'll just put a little mark there. That one's congruent to itself. Because these are parallel lines, they're cut by two transversals. We're going to have here two corresponding angles. And the corresponding angles are going to be the lower right on each of those triangles. You also have another transversal cutting those parallel lines, and so you have two more corresponding angles, okay? I'm going to put those, or I'm going to denote those with three little arcs, okay? And so we have similar triangles because of our theorem with parallel lines, all right? Another situation that you'll see with similar triangles, some people call this the bow tie example. It kind of looks like a bow tie. And let's see. Okay, so you make kind of an X shape, but the outer sides here have to be parallel. So something like that. Something like that. And so this side on the left, parallel with this side on the right. And again, we can look at alternate interior angles this time, right? So we have two parallel lines. I'm going to cut by transversal. Angle on the top left, angle on the bottom right are alternate interior angles. And so they've got to be congruent. Angle, same thing. Here's a transversal going up to the right. And so you have alternate interior angles on the bottom left and upper right. And then finally, the two angles in the middle are what we call vertical angles. We know those are always congruent. So we have three sets of congruent angles again, making for similar triangles, okay? All right, so those are two different situations you might see. Now let me give you an actual problem. We'll work through one problem here. Just to get you an example so you can work through the homework a little bit easier. Let's say we had a triangle. Looks kind of like this, and it has another smaller triangle on the inside with a side that is parallel to one of the sides on the big triangle. I don't know that I drew that very parallel. Let's try that again. A little bit better. Okay, so these two sides are parallel to each other. Then we know that they're similar triangles, the small one and the big one. All right, so let me put some side measurements on there and we'll calculate an unknown side. Let's say that we knew the left side of the big triangle was 6 units. Let's put some units on it. Let's say 6 inches. Let's say the big triangle, the bottom side, was 10 inches. The bottom side of the small triangle is 4 inches. And what we want to find is the left side of the small triangle. I'm going to call it side A. All right. And so to find the missing side, I'm going to use the idea that the ratio of corresponding sides are equal. That's our theorem for similar triangles. Okay, and so I'm going to set up 2 fractions where you take corresponding sides of the 2 triangles and divide them. So corresponding sides are 6 and A. And we know those have to be equal to the sides, the ratio of 10 to 4. Notice I have the corresponding angles are in the same fraction, but I was also careful to put the sides from the same triangle in the same position. So the big triangle, the sides from the big triangle, both go on top. The sides from the smaller triangle both go on the bottom. Okay, otherwise these proportions don't work out. And so now we solve, and of course to solve a proportion we use cross multiplication. 6 times 4 is 24. And 10 times A is 10A. So we have 10A equals 24. And then, of course, we divide out the 10. And A would equal 2.4. Right, 24 over 10. So the missing side here is 2.4 inches. All right.